Hey QED coders, Michael L. Perry here. When we talked about REST, we needed to know whether we already knew about a fact. And that leads us into a discussion of identity and uniqueness. And so that's what we're going to be talking about today. Identity and uniqueness are important for solving three central problems. 1, idempotence, which we've talked about at great length. 2, collaboration, making sure that different clients are talking about the same thing. And 3, location independence. And that's making sure that we are talking about these facts no matter where they're stored. Their identity is independent of their location. This is going to be really important for distributed systems, as you might expect. Now, in a historical model, identity is defined using 3 attributes. 1, we've got the type of the object. Number 2, we've got its values. Remember, it's immutable, so the values can't change. And number 3, we've got its predecessors. That's the set of all of the previous facts that must have come before this one. And since a fact is immutable, its predecessors are also not going to change. So these 3 things taken together give the identity of the fact. Nothing more. So we don't have any external ID that's been assigned by, say, a database doing an insert. That's not the identity of the fact. The identity of the fact is just these 3 things: type, values, predecessors. That's it. So how does this apply with the example that we talked about last time? Let's say that we're doing a post to the catalog, and we're posting a new item. The type of this object is myApplication.item. It's just the namespace and the type. The values, that's the collection of values. It's only got one value in this case. ID is item 3. And predecessors, that's just the catalog. So if I already have a record that has these 3 attributes, then I already know about this item. If I don't, then I insert it and I say that it's created. Now, how does this map to our historical database? The type is going to map directly to a table. I'll have a table called item. The values are going to map to columns of that table. So I'll see within that table I've got a column that's called ID, and then the predecessors are going to map to foreign keys, also columns of that table. Now, this table also has a few extra things that are useful for bookkeeping. Like, for example, we do have a machine-generated ID. But remember, that's not the identity of this fact. The client never knew about that ID. And then when I say that this thing was created, I don't give that ID back to the client. I'm going to keep that ID just within this database structure. So what about putting a new version of Immutable Properties? So I'm going to put a new name to this item. So let's suppose the name is already widget, and I want to change the name to gadget. So I'm going to put to this item's URL a structure that carries with it the values and the predecessors. So the values, it just has one value. Value is gadget. And the predecessors, well, there are 2 predecessors that come along with it. One predecessor is the item that's identified by the URL, and the other predecessor in this structure is the fact that the name used to be widget. So we're carrying with it that predecessor and the new name that I want to apply. And so now from that, I can derive the identity of the fact that I'm trying to insert. The type is myApplication.item.name. The value is value equals gadget. And predecessors, well, that's the collection of both the item 3, and the fact that set the name to widget in the first place. So those 2 facts are both predecessors of this new one that I'm trying to insert. So now I look in my database and I see, do I have a fact that matches this? So let's map these 3 items, these 3 attributes, into my database structure. So the type maps to a new database table, which is carrying the item names. So item name is the table. And then the values map to columns. And so in here, I've got the column value. And then the predecessors, that includes the foreign key to the item and the foreign key to the previous item name, the one that set it to widget. Now I can't store that foreign key directly in this table, so I create another table. This is my item name predecessors table. And so this carries the IDs of all of the predecessors for any given item name. So I've got a predecessor foreign key and a successor foreign key. So for a given successor record, I can look up all the predecessors. And so now I can look in this set of tables and I can see, do I already have a record of this particular fact? If I do, I don't insert anything, I just respond OK. If I don't, I insert something and then I respond OK. So I'm being idempotent on the put. So this definition of uniqueness and identity of historical facts, the name, the values, and the predecessors, allow me to be location independent. So now anybody who's talking about this fact is going to know those three things, and they're going to agree on those three things. But they're not going to know any machine-generated ID. They're not going to know any auto-incremented number that was generated upon insertion. They'll have these three things when they're first trying to insert the record, and so these three things will be its identity. And now any client that's talking about the same type, values, and predecessors is talking about the same fact, and that allows them to collaborate with one another. Now there's something that I really want to share with you, an example model of all of the things that we've been talking about so far on the Historical Modeling channel. So this includes a sample database, a REST API, all of the source code in a GitHub repository, and you can find all of this information at historicalmodeling.com. So go check it out, download the sample, give it a try, and see what you think. And then to continue the conversation on identity and uniqueness, we're going to be talking about how we use natural keys inside of a historical model as opposed to surrogate keys. So stay tuned, and let's talk about natural keys on the next episode.